Welcome to this week's episode of High Performance Rejects. We're working on getting the seatbelt situation fixed now that I've moved the seat, because if you don't know, there are ways that you can mount your racing harness correctly and incorrectly. And in moving the seat, I've actually made them incorrect because the angle is wrong, which will make the seatbelts less effective. And you kind of want your seatbelts to work if you get in an accident. So let's get into how I'm going to fix that this week. On this car, I have a 4-point harness system, and this was originally installed using a factory seat. And with my dad's positioning, these were mounted in a way that was within spec. However, in putting the seat in, I've raised how high these need to go. Also being a taller person, that's changed. And I've changed the angle of the back here, which all goes into the proper mounting of these seats, or these seat belts, sorry. So let's get you on the back side of that. That looks all well and good from the front, but the issue comes when we look back here. The angle of the back of the seat to the where this strap is needs to be 90 degrees or more horizontal here, so that in an impact these aren't trying to bend down. So if I were to go forward, the bigger the angle of this going down, some people actually tie it to this lower bar here, creating a U. That U is just going to fold forward, not actually retain you when the seat breaks, or if the seat breaks. The seat belt's not really what's holding you in. So changing the seat, this is less than 90 degrees now, so these need to be raised to get them back into the recommended position to keep tension and properly hold you in the car. But on top of that, we can see how long this belt is behind the seat. The longer this is, the more the belt's going to stretch on an impact, which will slow your decel a little bit better as you hit the impact, so it'll be a little bit more comfortable. However, the more I'll move, and the more likely I am to smack my head on the cage, because these aren't going to be holding me quite as well. And on top of that, you see these mounting points are not attached to the main hoop. They're on the structure behind the main hoop. There have been scenarios where impact has actually sheared the back half of the car off. Driver stayed with the main cage, but their seat belts were attached to the back half of the car, and that ended up taking the driver's life, sadly. So my preference is to make sure that the seat belts are tied to a bar that's attached to the main hoop, reducing the chances that in an impact where I'm sitting and where these seat belts are mounted is going to move. So let's start figuring out how we're going to bend up a tube and get this welded in to correct this angle and have the attachment point as close to me as possible. Which hopefully isn't too bad, but let's start doing some math and some planning. So to make the tube, I use handy dandy cardboard fiber because it's cheap and plentiful, especially in this day and age of everything's ordered online. So it's coming to your house and be held on to make stuff with, or at least help you fabricate things. Using these templates to figure out my spacing on the cage and how far I need to clearance away from the seat, and then also use this to do the math as to how we need to lay out our measurements on the straight tube to come up with our bent tube. But we're starting with what our bent tube would be, so we can see that it fits, and measuring the straight sections to what would be considered our bend tangent line. So that's the point at which the tube goes from being straight to being bent. Then our next bend tangent line where it goes back to being straight. And then because this is mirrored, it's going to be the same bend allowance through this bent section and then another same straight section, which of course the straight sections you literally just measure on your template for your bend allowances, so how much material is going into this bend, which you're assuming based on the center line of that bend being your radius. You can do the math. So in this case, I've got a mandrel here. I can figure out what this radius is. I can measure the angle from my template and either do the math of the percentage of a circle it is. So 90-degree bend is going to be 1/4 of a 360-degree circle. Radius being known, you can do the equation of pi d or 2 pi r to find out how much material is in a 360-degree circle. 90 degrees being 1/4 of that, you just divide the number by 4. Or the fabrication charts will divide that number by 360 to give you how much material is in 1 degree worth. So once you know how much angle change there is in this bend, you'll say you've got a 6-inch radius. It tells you how much material you need per degree multiplied by the number of degrees you're using, and that'll give you the amount of material that you need while the bar is straight to allow for this particular bend. In my case, I don't want to do math. I don't want to have to measure this radius. So on my template, literally putting this is going to be the bend radius since this is on center. Mark where one bend tangent is, mark where the next one is once bent. Take a ruler, something you can bend along there, and measure literally how much material is in that bend. And that gives you how much material you need when the bar is flat to get there. So in this case, my template showed 4 inches of a straight section, 1.5 inches for each of my bend allowances, and I need 34.5 inches of straight section. So you just lay that out on the straight tube. And in my case, because this tubing bender has to start at the middle of the bend, and then you bend until these two ends are also now tangent to this. I need half that, so I need a sight line at 3/4 of an inch beyond my 4-inch edge. And we can do the math to get that on the other side so we can have our final product. So using cardboard and just simple measuring techniques can help you lay out where you need to start for flat to having your bent shape. Now my problem is, even though I now have my tube that's bent and I just need to go and carefully fish mouth to put it in, I'm not happy with the Harbor Freight tubing bender, as it left nice little divots despite trying to lube them up and hope that they roll. They still dug in. And even with this little bit of a bend, you can see that it flattened out the outer radius, which is less than ideal. I'm sure that this will work just fine for seat belts. It's not going to fail in a crash. But with my own personal preferences, I don't like having that little dent. So I'm going to use this math to go somewhere where I can use a good tubing bender and properly bend one of these without dents in it. That's just going to be scrap. So hope you learned something today about seatbelt safety and a little bit about how to fabricate something that needs bends to lay out your measurements of starting flat to bending something, because this also applies when you're bending sheet metal. It's all the same math. So thanks for watching. Have a great weekend. Oh, welcome to this week's episode of High Performance Rejects. I'm getting back on Warhorse, and in this case, English, hard. Try this again. So welcome to this week's of High Performance